So in this video, we continue our work with solving quadratic equations using the completing the square method. And so we're going to go right to example number 4. We have x squared plus 4x plus 10 equals 0. So again, your first step, check that a. That leading coefficient has to be 1. Okay? And it is. So good. We checked it. So a equals 1. Check. Okay. The second step, move the constant. So we're going to subtract 10 from both sides. So now we have x squared plus 4x plus, we're going to add something there. So leave space to add the constant when we complete the square. Here we have negative 10 that we just moved over. And then plus, okay, whatever we add to one side, we're going to add to the other side. So that's why we have the two spaces. Okay, step number 3. This is where we complete the square. So we're going to look at b on the left-hand side, which is 4. b equals 4. We're going to take half of that. So half of b is 2. We're going to square that. So 2 squared is 4, and that's what gets added here. Different color. Here and here. Okay. All right. Next step is to factor. So the left-hand side, we completed the square so that we could factor this as a binomial squared. It's x plus 2 squared. And then on the right-hand side, we're going to add a negative 10 and a positive 4 and get a negative 6. Next step is square root property. So we're going to take the square root of both sides. And we're going to remember that plus or minus on the right-hand side, right? So square root property, so square root plus or minus square root of negative 6. So here we have x plus 2. And here we have a negative radicand. We have a negative under the square root sign. So if you remember that, that means complex number, imaginary numbers, you're absolutely right. So let's factor out that I, right? So this is negative 1 times 6. And we're going to take square root, and the square root of negative 1 is I. So this becomes plus or minus I times the square root of 6. Okay, so that means we have two equations to solve. We have x plus 2 equals positive I square root of 6, or x plus 2 equals negative I square root of 6. Add the 2 over, or subtract 2 to solve for x. So x equals negative 2 plus I root 6, or x equals negative 2 minus I root 6. And that means that our roots are two complex conjugate roots. Do you remember what that meant? They're conjugates because that middle sign is these two signs are opposites in the middle. So we have a plus bi here. I put the I in front though, right? And we have a minus bi here. These are complex conjugates. Okay. All right, let's go to number 5. Again, a is 1. Move the constant. Leave the x squared minus 5x plus, leave room for completing the square. Negative 3 plus, leave room for completing the square. Okay, so now we're going to complete the square. And b is negative 5. And we need half of that. So this is not an even number. So I'm going to make it into a fraction, put a 1 under it. And this means that half of b is negative 5 over 2. And now you need to square that. So square this negative 5 over 2, and we get 25/4. Yes, this ugly fraction gets added here and here. So 25/4. Okay. So to factor the perfect square trinomial on the left, if you recall from our previous work on completing the square, we're gonna, this guy that you squared, that's what goes here. -5/2. Okay. Equals, over here, I have a -3/1 plus 25/4, and I'm going to get a common denominator of 4. So here is -12/4 plus 25/4 to combine those two fractions here. And so that means like I have a 13/4. So that's what comes over here, 13/4. Okay, I know this is looking bad, but we got it. We got this. Okay, what's the next step? If you said square root property, you're right. And then we're going to remember that plus or minus, right? On the right-hand side. So square root plus or minus square root. So here we get x minus 5/2. Now, over here we have, I'm going to go ahead and split up that square root of a fraction. I'm going to take square root of 13 over square root of 4. Do you see why I did that? Because square root of 4 is a perfect square. So we have, let's rewrite, x minus 5/2 equals plus or minus square root of 13 over 2. And now we have two equations to solve. So the first equation will be x minus 5/2 equals a positive square root of 13 over 2, or x minus 5/2 equals a negative square root of 13 over 2. Add these over, these 5/2. So x equals 5 plus square root of 13. And we can put it all over 2 because they have a common denominator. These are not like terms, so we're going to leave them like that. Or x equals 5 minus square root of 13 all over 2. And what kind of roots are these? Since you have those square root of 13s, if you said irrational, you're right. Irrational roots. Okay, I know that one. That one had a lot of interesting pieces to it with all these fractions, so you may want to rewind this and watch it again. Okay? All right, let's go to number 6. So now in this problem, you notice that the constant, that we have 8 already on the other side of the equation. So this problem is ready for you to complete the square, right? So the first step would be just make some room for what you're going to add here. Okay? All right, so now what I want you to do is I want you to try this. So I want you to pause the video, give this problem a try using the last problem as a guide, and then when you unpause the video, you're going to see what the solution is, and you can check your answers. Okay, so pause your video now. Okay, so here's the solution. B is 7. So when you take half of B, you have 7/2. And when you square that, you have 49/4. So did you add 49/4 to both sides of the equation? Then did you factor on the left-hand side, x plus 7/2 squared? And on the right-hand side, kind of nice, when you added the 8 over 1 plus 49/4, you got 81/4. And why is that nice? Because when you take the square root property, did you remember your plus or minus on the right? But when you take your square root property, 81/4 is a perfect square. So we get 9/2. Now you're going to split your equations into two equations. X plus 7/2 equals 9/2. And notice on the left, I subtracted 7/2 and got x equals 1. And the second equation, x plus 7/2 equals negative 9/2. And when we subtracted 7/2 there, we got that x equals negative 16/2 or negative 8. So in this particular case, we have two rational solutions, negative 8 and 1, as the solution to this problem. So how did you do? Okay, so now I have a note for you, little hint. Anytime that we get two rational solutions, like we did with this problem, that tells us something about the quadratic equation. That means that this quadratic equation factored. So let's check that out. So here's our original equation. And if we're going to try to factor, we know that we need a 0 on one side, so we're going to subtract the 8. So x squared plus 7x minus 8 equals 0. And let's factor that. And that's x plus 8, x minus 1 equals 0. Set these to 0 and we get x plus 8 equals 0, or x equals negative 8. X minus 1 equals 0, or x equals 1. And so notice that we get the same answers, which was expected. And like, which one was less work? Well, if your factoring skills are good, then of course this second method I think was easier, don't you? So when you're asked to solve quadratic equations, if you're not specified, if your teacher doesn't say you have to do it by completing the square, it's always a good idea to see if the quadratic equation factors first, because sometimes that makes the problem a lot easier to solve.